In this question, we want to integrate sine squared of 2x using power reduction formula. If you know how to do this, why don't you try it yourself first? So we want to integrate sine squared of 2x. Power reduction formula will help us do that. What that means is we'll get rid of this square here. Let's start with cos 2x, and we know cos 2x is x plus x. And the addition rule for cos 2x is cos x times cos x minus sine x times sine x. That will give us cos squared x minus sine squared x. At this point, you notice there's a sine squared here and there's a sine squared here. We don't want the cos squared x, so we change that to 1 minus sine squared x. That's from the Pythagorean identity, which states that cos squared x plus sine squared x equals 1. That will give us 1 minus 2 sine squared x. We can say then that cos 2x is 1 minus 2 sine squared x. Now we try to isolate sine squared x. We add 2 sine squared x to both sides, and we subtract cos 2x from both sides. Now we remove this 2 by dividing through by 2. We get sine squared x is a half minus a half cos 2x. Notice, however, that we have sine squared 2x, and this is sine squared x, and this is cos 2x. So we multiply this angle by 2, and we multiply this angle by 2. So sine squared 2x is a half minus a half cos 4x. Therefore, the integral of sine squared 2x is the integral of a half minus a half cos 4x. This is much easier to integrate. We want to integrate half dx minus a half cos 4x dx. This is our standard integral for cos ax dx, which is 1 on a sine ax plus c. You could also integrate this using the substitution method. So we integrate a half, we'll get a half x, and integrating cos 4x, we'll get a quarter sine 4x. Multiply now to remove the bracket. So we have a half x minus 1/8 sine 4x plus c. In conclusion, the integral of sine squared 2x dx is a half x minus 1/8 sine 4x plus c. Thanks for watching.